Hello, and as I promised, this is the second part of chi-square, and it's a non-parametric test again, and this time we're going to take a look at a chi-square test for independence, okay? And don't forget, we're using this test to explore a relationship between two categorical variables, all right? And in this case, we're going to take a look at gender and whether they're a smoker or not. Okay, so let's go ahead and we're using the same Survey 3ED save that we used in the last test for not the test for independence, but the goodness of fit. And this time we're going to do the test for independence. So let's go ahead. And the first thing we want to do is turn to page 214 in the survival manual and go down to the bottom of the page. And I just want you to look here at some assumptions. And don't forget that I'm reading additional assumptions for chi-square. The lowest expected frequency in any cell should be 5 or more. Okay, that's expected frequencies, FE, not FO. Okay, so let's go down to the gray box, and from the menu at the top of the screen, let's go to Analyze, and this time we're going to go to Descriptive Statistics, and we're going to go to Crosstabs, or Cross-Tabulations. Okay, we're going to click that, and I've already got sex and smoker in the box, and I'll take them out, just so you could see how we put things in and take them out. And so for our rows, we're going to want gender. And you could do it the other way. It doesn't really make any difference. But in this case, we're going to put males and females in the rows, and then we're going to put whether they're a smoker or not in the columns. Okay, and then we're going to go to statistics. Okay, and the book is telling us that we want the chi-square. So let's click chi-square, and we want a measure of strength, so let's click phi and Kramer's V. All right, we're not going to do lambda, and we're not going to do the contingency coefficient. We talked about those, do you remember, in the video that we did last week. For this case, we're going to use phi and Kramer's V. See if you could remember why we're going to use those two, okay, or phi particularly. I'm going to click continue, and the next thing I'm going to do is go to the cells button and click that. And I don't want to clutter up my table, but I could put the expected and the observed frequencies in. I just want the observed frequencies in right now, because with SPSS you'll see that it's going to give it, we don't have to do the math, so we don't really need the expected frequencies up there. I do want the percentages though, okay, so I'm going to go row, column, and total percentages, because I do want to report that. And I'm going to say continue, and my next thing is I'm really ready to go. And if you're following along, take a look that you have it set up the same way I do, and just go ahead and click OK. And you'll notice that in the output box you have a lovely group of tables here, okay? And let's take a look. We generated a 2x2 table, and we have, here's the 2x2 table. So let's go ahead, and we have a N of 436. 99.3% of them are valid, and we're missing 3, and the 0.7 is missing. So let's just go ahead now and take a look at, turning to page 216, and we're going to take a look at some of the assumptions. The first thing that we should check is that we haven't violated one of the assumptions of chi-square by not having minimum expected cell frequencies, which should be 5 or greater, okay? And if you look over here at A, SPSS is telling us that we have 0% of expected counts of less than 5. So we're good. That assumption is good. We don't have to worry about that, okay? And don't forget, it's telling us here, B, that the continuity correction and that's Yates continuity correction. Yates, I'm saying, Y-A-T-E-S, is computed just for a 2x2 table. So when we report this, we're going to report it with something called a Yates continuity correction. Okay, but here we go. Let's take a look at the chi-square test, and the main value I'm reading here. The main value that you are interested in from this output is the Pearson chi-square value, which is presented in the chi-square test right here. All right, and if you have a 2x2 table, it says that is, each variable has only two categories. You should use the value in the second row. Okay, and that's the continuity correction. So normally we would use this. We have a 2x2, so we're going to use the continuity correction. Okay, and this is Yates correction for continuity, which compensates for the overestimate. You don't have to worry about that. Just go ahead. You know that when you have a 2x2 table, you're going to use a continuity correction. In the example presented, the corrected value is right over here, is 337. Okay, let's take a look at the cross tabulation. To find what percentage of each sex are smokers, you'll need to look at the summary information provided in the table labeled sex asterisk smoke cross tabulation. Okay, and if you look right over here, you'll find that this table may look a little confusing, as it says to start with, because there's a lot of information in there. To find out what percentage of males are smokers, you need to read across the page in the first row. So males, you read right across the page in the first row, and it refers, of course, to the male population. In this case, we look at the values next to the percent within sex. Okay, so percent within sex. You could see, for this example, 17.9% right here of males were smokers, while 82.1% right here were non-smokers. Okay, so yes, we were smokers. No, we weren't smokers. Okay, and if we wanted to know the percentage in the sample as a whole smoked, we would just move down to the total and look at the row total, okay, over here. And it's the same with the females. So if we look within sex, we see that 19.5% of females smoked and 80.5% did not smoke. Okay, and let's take a look at the effect size. There are two numbers of effect size statistics available in the crosstabs procedure. And I'm reading right from the book here for 2x2 tables, and the most commonly used one is the phi coefficient, which is a correlation coefficient and can range from, you remember we talked about this, from 0 to 1, with higher values indicating a stronger association. So the closer it is to 1, the stronger the association. Okay, so let's just go ahead and take a look at the value for the phi is 0.034, and the Kramer's V is 0.034. Okay, so we know that we're getting, what do you think? The approximate significance is 0.482, and we'll actually read from the book here. So with higher values indicating a stronger association. The phi coefficient value in this example is minus 0.034, which is considered a very small effect using a guy named Cohen's criteria for a meaning 10 for 0.10 for a small effect, 0.30 for a medium effect, and 0.50 for a larger effect. All right. Let's pop over to the way to write this thing up. So we have the percentages up here, and we have the chi-square here, which is 0.494. We have the asymptomatic significance for a two-sided test here, which is 0.482, and we're just going to go ahead and take a look at the phi and the Kramer's V. They're identical, so this is the way we would write this up. A chi-square test for independence, and don't forget we're using this Yates continuity correction because it's a 2x2 table. indicated no significant association between gender and smoking status. Okay, and then we're going to write up the APA sentence here. It says chi-square, open parentheses, 1, which is the degree of freedom, comma, n equals 436. Where did we get that from? We got it from the total number, 436, equals 0.34. Okay, right here. The phi is 0.34, and the p-value is 0.56. Okay, and where are we getting that from? With the continuity correction, we're getting the significance from right here. That's the p-value, 0.56. And what is that telling us? And phi is minus 0.03, and we just truncated, took that 4 off. So what is that telling us? It means that there is no significant difference between the sexes in number of individuals that smoke. Okay, they're very close. So that was easy enough, wasn't it? We'll try using SPSS for some of the homework problems to just kind of show you how to stick it in there and work SPSS to help you with your homework. Okay? If you have any questions, and practice this, just set up some different stuff. If you want me to send you more data files, I will. And we'll go ahead and learn a lot more about chi-square this week. See you later.